Okay, so we're going to start, actually we're on Learning Target 1-4, not sure why I have 1-2 there. Okay, so 1-4, we're simplifying expressions, and we're going to kind of fly through this again. I know I've said this a lot for Unit 1 videos, only because Unit 1 is really, really a big review for advanced algebra, but a review is good nonetheless. So I can simplify expressions, and we're going to kind of do this in 3 parts. So we learned how to combine like terms last year. Okay, sometimes it's called adding and subtracting expressions. So for example, if I were to look at this as adding expressions, 4a plus 3 minus 7a minus 2, okay? So adding this expression, if I'm adding this binomial to this binomial, we'll learn that word later, I'm combining my like terms. And if you had me last year, we kind of used something color-coded. We said, okay, like terms, first of all, you have to remember this from last year, are the variables, or both terms that have the same variable parts. And then these are your constants. So you're going to combine your variable, your terms with your variable, your terms without your variables, which are your constants, and you get 4a plus a negative 7a. Remember, that's really important about combining like terms. So this really is 4a plus negative 7a, but we don't do the double signs here. This is, everything is addition, right? Because subtraction is defined as adding the opposite, so don't even look at it as anything but addition. And you're combining these two terms, so that gives you a negative 3a, and this gives you also, take the sign of the larger, positive 1. So we just combine like terms by adding that expression, okay? If I were to ask you to combine these, or subtract these two expressions, meaning 4a plus 3 minus, let's say 7a minus 2, okay? All I did was we could even put this here. All I did was here I added them, and here I'm subtracting them. So this requires you to do something a little different. It's saying subtract this whole expression from this whole expression, and before you can do that, you can't just subtract the 7a, you have to use the distributive property, remember? So you need to take the opposite, it's called sometimes, of this expression before you can do your adding. So nothing would change here. This is the opposite of a positive 7a and the opposite of a negative 2, which is a positive 2. And so now once you distribute that negative, then you can go ahead and combine your like terms. So we still have a negative 3a. This time it's plus 5. Okay, so that's combining like terms, okay? Then we learned the distributive property. We learned about this in Unit 1-1 when we defined our properties. And we learned that the distributive property says if I have 5 times 3 plus 1, I know order of operations says go ahead and do the 3 plus 1 first and then multiply that. But we also learned a property that instead of just adding that, you can multiply each term in the parentheses by 5. And that would look like this. 5 times 3 added to 5 times 1, 15 plus 5, and there's your 20. Now, if we're given this problem, you probably wouldn't do it this way. But if you were given this problem, you would have to do it this way with the distributive property because a negative 3a and a 7 are not like terms. And so I don't care what the order of operations says, you can't combine the negative 3a and a 7. So you have no choice but to do this here. So you're going to do a positive 5 times a negative 3a. And I know I'm not going to have you show the work like this because sometimes that can get confusing. You're going to go right to an answer. So 5 times negative 3a is negative 15a. And 5 times 7 is a positive 35, okay? You just have to be a little careful when that 5 becomes negative. Let's say negative, let's say x minus 10, okay? This is a negative 5 times x, which is your negative 5x. And then a lot of people will ask when we're combining terms, or distributing, how do I know what sign to put in the middle? And I don't really want you to look at it as what sign is the middle sign. I want you to look at it as what is the sign of the end term. If a negative 5 times a negative 10 is a positive 50, then that's a positive 50. So remember, we're looking at these as signs and not operations. So this is a positive 50, that's a negative 5, okay? So another example here would be 4 x times x minus 7, Okay, and I'm purposely doing this one because you are going to be asked to distribute a variable to a variable, okay? And up here for combining like terms, if I would have asked you to add a 5n plus n plus n, so that's 5, that's 1, and that's 1. So n plus n is n, 2n, okay? So plus 5n. So this would actually be 7n, right? N times n, however, is going to be n squared, which would mean when you are distributing a variable, it's going to be x times x, which is going to be x squared. I want you to look out for that on the practice today, okay? So this times this is x squared, not x, and this times that is your negative 28x. Do you see why I put a minus there? Because that positive 4 times that negative 7 is a negative 28x, and that's why I put that minus, okay? Same thing can apply for if I have this on the outside, a plus 6, okay? I could do negative times positive is negative 5a squared. Negative times positive is negative 30a, okay? So, if you know how to combine like terms or add and subtract expressions, if you know how to distribute, then part 3 of today's notes is going to be putting these two together in the same problem, okay? And that's going to look like this. So we're going to say combine like terms and distribute, all right? And I know you did tons of equations like this last year, so that's why we're just kind of doing a quick review. So let's take this 5x, well actually let's do the x yet. So 5 times x minus 7, and then let's say plus x, all right? And the way that I taught this last year was identify what you have to do first, because now order of operations comes into play. So what can I add this x to? Nothing yet, because you can't do addition before you do multiplication, right? So I had my kids put a box around your main first thing that you need to do. And what that is you're going to distribute, you're going to find the parenthesis, and you're going to include in that box the number that needs to be distributed. So then it's kind of like everything else that's not in that first step gets brought down. It gets recopied, kind of like an order of operations problem would, right? So then now that I distributed, then I go to combine. So that's always going to be your combine. Okay, distribute means multiply, combine means add. All right, so now I have 5x plus 1x, which is 6x minus 35. Okay, that was a pretty easy one. So let's complicate it a little more. Let's put something in front. Let's say 8 minus 3 times negative 7 plus a. Okay, so when you are, notice the variable doesn't have to be always in the first spot. So I'm going to take that box, I'm going to put it around the parentheses, and here's what's tricky. What am I distributing, a 3 or a negative 3? So you are going to have signs messed up if you do not distribute the correct sign. That 3 is not positive, it's a negative. That's not a minus, that's a negative sign that goes with that 3. So what's going on with the 8? Nothing yet. Okay? 8. Negative 3 times negative 7 is, look, positive 21. Negative 3 times positive a is negative 3a. And now it turns into a adding problem. So add your like terms, and here, these are your like terms. I don't have another a to add with these. And the order of your answer, usually I like it to be in alphabetical order and your constants at the end. Okay, if you were to just look at this problem and make this 29 minus 3a, I'm not going to mark you wrong for that. Okay, that's a totally acceptable answer. What I do need you to know, though, if while you're doing this and you're checking your answer key, but your answer key says negative 3a plus 29, you're good. You know that. The 3a is negative, it's still negative, the 29 is positive. Okay, what you can't just do is switch those two around. And you know that. And you know why you can't do that? Because we learned it in 1-1. Subtraction is not commutative. Meaning you can't take the 3a, leave that, and put that there. You know you can't, because subtraction is not commutative. This is the same as that, this is not, okay? And then they might get fancy, and then you might have some double distributing to do. You might have -6 minus, and then maybe there's no number there, 3x minus 2 plus x times x minus 5. Okay? Holy cow, let's look at this one. Then you're finding your parenthesis, and you're distributing a positive x to that. And you're distributing, I did this one on purpose because a lot of people get so confused when there's not a number there and they want to distribute that -6. No, you are distributing a -1. You are multiplying this whole equation by -1. And all that happens when you multiply by -1, we learn that in properties also, right? It's the additive or multiplicative inverse property. It changes the signs. So this -6 is hanging out. -6. Change that to a -3x. Change that to a +2. Because that's what multiplying by -1 does. Then this becomes plus x squared minus 5x. Okay, and I wanted to end this problem specifically because when we talk about like terms, it's really not the best thing to say, oh, like terms just have the same variable. Add your a's with your a's and your b's with your b's and you're good. And that's not really a complete definition because technically there's x's here and there's x's here. However, these are not like terms simply because they both have x's. So the definition of like terms have the same variable. They have the same variable part. Adding that one word in there means if there's a coefficient, so this coefficient is -5, this coefficient is 1. Is the part after the coefficient identical? No. This is 1x, this has 2x times x. So when you rewrite your answers, and sometimes if you have a lot to look at, it's helpful to kind of draw those lines in there. And remember, there's no subtraction in algebra. It's adding the opposite. So this is all adding. So how do I want to look at my answer? So if we go back to using this color code, so I have 1x squared. I'm going to put that x squared answer there. This is called standard form, and you're going to learn this in Unit 7. Then you put your x term answer there. And then you have your constant term, which will go last. So hopefully this little visual kind of helps you figure out how you put your answer. So I'm going to put my x squared first. And you know what some people like to do? They don't want to have to look at it anymore because that's a lot to look at. So then I'm going to move on to these two. That's a -3x. That's a -5x, which look, gives me a total of -8x. Done with that. Done with that. And now I have a -6 but a +2. I added these two because they were the same sign. I'm subtracting these two because they are different signs. Okay? So this brings up a great question. What if you had a -8x plus x squared minus 4 is your answer? Am I going to mark it wrong? No. Because in Learning Target 1-4, it does not specify, like Unit 7 does, put your answer in standard form. We're going to learn that. But that's okay. So guess what? What's another possible answer? You could have your -4 first, then your -8x, then your +x squared. You could even switch these two around. There's a lot of ways to do this. But to make my life easier when I'm checking for you or you're checking your answers, standard form, I'll just throw that out there. Standard form of a polynomial, which I know you don't know what that is yet. It's only September 7th. It means go with your highest exponent down to your exponents of 1, down to your no variables, constants at the end, okay? And then keep in mind that you may have some rational numbers in your problems. For example, 1/3 times 2/5 a plus, we'll make this easy on you, 9, okay? So you're going to have to remember this. This is Learning Target 1-2. I can perform operations with real numbers. Real numbers are fractions, decimals, all kinds of things. You have to add them, subtract them, multiply and divide them. So I need to multiply this. And luckily for you, multiplying is kind of easy. If you cannot cross cancel, you literally just multiply numerator times numerator, denominator times denominator. So this is 2/15 a, And then 1/3 times 9, if it's easier for you to do it that way. That way this works out to be a whole number. And then this doesn't have an A, and this does, so I cannot combine those. Those are done. That's your answer, okay? So keep in mind, you're going to have some real numbers. You're going to have some decimals. You're going to have negative 0.5 times 0.3, A minus 1.7. Multiply and do the problems exactly like you would do the other problems, just using your decimal rules instead, okay?